Welcome, science fans, to a very special place. This is a chemical engineering laboratory. It is a place of wonder, a place of discovery, and a place where ideas become real. Look around. You see pipes, tubes, beakers, and cool machines.
Two bright students, Maya and Leo, are here today. They are ready to explore the world of chemical engineering.
Their supervisor, Dr. Evans, is here to guide them. She is a scientist who loves to ask questions and find answers. Science is all about curiosity. It's about looking at the world and asking, how does that work? Or what if we tried this? That is exactly what we are going to do today. Let's get started.
Maya and Leo are putting on their lab coats and safety glasses. Safety first, always.
Dr. Evans smiles. All right, team, she says, what's our mission for today?
Leo checks their lab notebook. Our first task is to concentrate a sugar solution. We need to remove some of the water to make it more like a syrup.
Maya adds, then we're going to separate a mixture of alcohol and water. And finally, we'll test the color of a sample.
These might sound like simple tasks, but they are the building blocks of so much in our world. Think about making juice concentrate, purifying water, or even making medicines. It all starts with experiments just like these. Dr. Evans points to a large, shiny piece of equipment. Excellent. So, for the sugar solution, which piece of equipment will be our star player?
Maya looks at the machine. It has a big glass chamber and lots of tubes. That would be the evaporator, right? She asks. We can heat the solution gently under a vacuum. The vacuum helps the water turn into vapor at a lower temperature. This way we don't burn the sugar.
Dr. Evans gives a thumbs up. Exactly. We are changing the pressure to change the boiling point. That's some cool physics and chemistry working together. It's a gentle way to get the job done.
Leo chimes in with a question. Why is it so important not to burn the sugar? It would still be sweet, wouldn't it?
Dr. Evans nods, appreciating the question. Great question, Leo. If we burn the sugar, we cause a chemical reaction called caramelization and then pyrolysis. This changes the sugar molecules themselves. The flavor would change from sweet to bitter. The color would turn brown, then black. In chemical engineering, we often need to preserve the exact properties of our materials. So, controlling our process conditions, like temperature and pressure, is absolutely critical for a successful outcome. It's all about control. Now let's get that evaporator running.
Leo carefully pours the clear sugar solution into the machine's feeding tank.
Maya starts up the vacuum pump. You can hear a low hum as the air is pulled out of the system. Look, Maya says, pointing to a gauge. The pressure inside is dropping. This means the water will boil much more easily.
Dr. Evans watches them closely. Perfect. Now, let's apply a little bit of heat using the steam jacket. We don't need much. We just want to give the water molecules enough energy to escape as vapor, leaving our concentrated sugar solution behind. It's like making a magical potion, but it's not magic. It's science. As the solution heats up, tiny bubbles start to form. Soon, the water is boiling, but the thermometer shows a temperature far below the usual 100 degrees Celsius.
Wow, Leo says, it's boiling, but it's not that hot. The vacuum really works.
The water vapor travels up a tube and is cooled in another section called a condenser, turning back into pure water. Meanwhile, the sugar solution left behind gets thicker and more syrupy. This process is used in all sorts of industries, from making maple syrup to producing condensed milk. It's a powerful way to remove a solvent from a solution. Next, Dr. Evans leads them to another piece of heavy-duty equipment. This is a furnace. It looks like a very strong, insulated box. Sometimes we need very high temperatures for our reactions, she explains. Think about making metals from ore or creating special ceramics. That's where a furnace comes in. It can reach temperatures hot enough to melt steel.
Leo looks at the thick door. So, we wouldn't use this for our sugar solution, right?
Dr. Evans laughs. Definitely not. We'd have a black, smoky mess. We always have to choose the right tool for the right job. That is a key skill for a chemical engineer.
Maya asks, what kind of materials do you test in a furnace?
Dr. Evans opens the door to show the insulated interior. We might heat a catalyst to activate it before a reaction. We could test how a new material withstands extreme heat. We might even be studying a process called calcination, which uses heat to cause a chemical decomposition. For example, heating limestone to produce lime. Each experiment has a specific goal, and the furnace gives us the intense energy we need to achieve those goals. It's a real powerhouse of the lab, but one we must use with great care and respect. Let's move on to our next challenge, separating alcohol and water. For this, Dr. Evans says, gesturing to a tall glass column filled with packing material, we'll use this, a distillation column.
Leo looks up at the column. I know this one. It works because alcohol and water have different boiling points. Alcohol boils at a lower temperature, around 78 degrees Celsius, while water boils at 100 degrees Celsius.
Maya adds, so if we heat the mixture, the alcohol will turn into vapor first. The vapor will rise up the column, and then we can cool it back down into a liquid. That liquid will be mostly alcohol.
You've both got it, Dr. Evans says with a proud smile. The packing material inside the column provides a large surface area. This allows the vapor and liquid to interact many times as the vapor rises. This process of repeated vaporization and condensation helps us get a much purer separation. It's like having many little distillation pots stacked on top of each other. The more volatile component, the one with the lower boiling point, moves to the top, while the less volatile component stays near the bottom. It's a fantastic example of using physical properties to purify substances. After the distillation is complete, it's time for our final task.
Maya holds up a small vial containing a blue liquid. We need to know how blue this liquid is, she says. How can we measure a color?
Dr. Evans leads them to a compact, high-tech box with a small chamber. For that, we will use this spectrophotometer. It measures how much light a substance absorbs. Every colored substance absorbs certain wavelengths or colors of light and reflects others. The color we see is the color that is reflected. This machine shines a beam of light through the sample and measures exactly how much light makes it to the other side.
Leo places the small vial called a cuvette into the spectrophotometer. He types some commands into the connected computer. A graph appears on the screen. So this blue solution is absorbing light in the orange part of the spectrum, Leo observes, and the graph shows a peak, telling us the exact amount of absorption. We can use this to figure out the concentration of the blue chemical in the water.
Dr. Evans nods. Precisely. It's a very accurate, non-destructive way to measure concentration. From medical diagnostics to water quality testing, spectrophotometry is an incredibly valuable tool for any scientist or engineer. As they finish cleaning their equipment, Dr. Evans gathers Maya and Leo. So what did we learn today? We didn't just follow a set of instructions. We saw principles of chemical engineering in action.
Maya reflects for a moment. We learned that every piece of equipment has a specific job. You need to understand the science behind it to choose the right one. Using a furnace for a sugar solution would have been a disaster. We controlled pressure in the evaporator and temperature in the distillation column to get the results we wanted. It's all about control.
Leo adds, and we learned how to measure our results. It's not enough to just separate the alcohol, we need to know how pure it is. It's not enough to see that a solution is blue, the spectrophotometer tells us exactly how blue. These measurements are our data. The data tells us if our experiment was a success and helps us understand what happened. Without data, we are just guessing. Science is about knowing, and we can only know if we measure things carefully and accurately. Every number tells a part of the story.
Dr. Evans puts her hands on their shoulders. Exactly right. But there's one more thing we used today that was just as important as any machine teamwork. Did you notice how you both worked together? Leo, you handled the solution while Maya managed the vacuum pump. You asked each other questions. You double-checked each other's work. Science is a collaborative effort. By sharing ideas and helping each other, we can solve bigger problems and make fewer mistakes. Your communication was key to our success today, and that is a skill that will help you throughout your entire careers. So, there you have it. A day in a chemical engineering lab is a day of adventure. It's about using amazing tools to see chemistry happen right before your eyes. It is about asking questions, collecting data, and working together to find answers. From making our food safer to developing new sources of energy, chemical engineers use these very principles to change the world for the better. And it all starts right here with curiosity, a couple of lab partners, and a passion for discovery. Consider the following. Science is everywhere. So keep asking questions and keep exploring, because the next great discovery could be yours.